Hello everybody and welcome to my video for Module 3. Today I'll be taking you through some height and weight data which was pulled from a statistics online computational resources data of 25,000 records of human weights versus human heights from a 1993 survey which took place in Hong Kong. And because 25,000 data points is a lot of data points, especially for a short video, I just took the first 20 data points to analyze. Okay, so I have two quantitative variables here. I have the height in inches and the weight in pounds. And I want to figure out what the relationship between these two variables are. I also have the ID variable over here, which is just a listing of 1 through 20, indicating which observation is associated with which ID number. Okay, so let's figure out some descriptive statistics. Let's take the mean first. So in order to find the mean, I just sorted both of these variables numerically from smallest to largest. This, for example, is the height data in inches, and then the weight data in pounds over here right next to it. So in order to find the mean for the heights, I just summed everything with a sum function by clicking equal sign, typing in sum, and then highlighting the data that I wanted to sum, and then dividing that by the number of data points I had, which is 20, and then repeating this process to find the mean for the weight data. So the mean for the heights was around 68 inches, and the mean for the weights was around 130 pounds. Then in order to find some histograms, I made some frequency tables for myself. So this is the height frequency table, where I just sorted the heights into different bins. These heights are separated by about an inch, counted the frequencies, and then found the percents by dividing the frequencies by the total of 20. So in order to make a histogram of this, I want to highlight the data I want to include, which in this case is the height and the frequencies. I want to go to Charts, Column, Clustered Column, hack the bar chart into a histogram by removing the gaps, clicking on the data, and setting that gap width, which pops up to 0, removing the gaps, and allowing the bar chart to be transformed into a histogram. If I make this a little bit larger so we can see, down here are my height bins separated out as they are in the table by inches, and then over here is the frequencies listed. This is a pretty uniform distribution. Not really any kind of major skewing on one side or the other, perhaps a bit to the right, but other than that, looking pretty uniform. If I want to change the title, I can go up here and click around in that title box. So I want to make this frequency of heights. And then if I want to change the axis titles, I want to go to Chart Layout, Axis Titles, and then choose whatever axis title I want to add, and then typing into this, again, the same little editing box. So then I want to make a histogram for the weight data. So repeating that same process of making the bins. These bins are separated by about 5 pounds apiece because I tried making it with 1 pound differences, and that just looked like a completely straight line because of the massive variation in the weights. So again, you have the weights over here, the frequencies just figured out by counting how many people fell into that category, and the percents by dividing the frequencies by the total of 20 again. And so again, highlighting the data I want to include, going to Charts, Column, Clustered Column, clicking on the data points, and setting that gap width to 0 to hack the bar chart again. This distribution is more spread out. There's not really a super clear center or anything. And once again, you can, change the title, so frequency of weights in this case. And then again, we have the weights listed here at the bottom in pounds, and the frequencies over here. So again, if we want to go to axis titles and then putting in whatever kind of title we want. So as you can see here, I chose a vertical title, and the vertical title appeared here. Moving that over. So, oops. Now I want to get on to the items we learned this week, which is regressions and scatter plots. So I'll be making a scatter plot of the original data table here, the height and the inches. The height in inches and the weight in pounds. So to do that, I'll be selecting the data I want to include, charts, scatter, marked scatter, making it a bit bigger so we can see. Changing the title to, oops, height versus weight. And then inputting my axis titles again, vertical, I'll be doing W for short for weight, and then horizontally we'll be doing H for short in inches. And I chose to do height for my x-axis variable, otherwise known as my explanatory variable, because I wanted to see if when a person got taller, if a person started to weigh more. So I'll be using height to predict weight, which means that I want to use height to kind of explain weight, therefore explanatory and response variable. So now I'll be moving on to the correlation calculation. Which I found using the z-scores, but first we need to calculate the standard deviation, which is another descriptive statistic of these quantitative variables. So in order to do that, I just kind of broke down the equation into different steps. So this is the height, the difference between the score and the mean, or in this case the height and the mean, that difference squared, the sum of those differences over n minus 1, which in this case is 19, and then the square root of that, the sum over the sum of those differences squared over n minus 1. So after going through all of that, the standard deviation for my x variable, my explanatory variable, the height, was approximately 1.65 inches. And then if you repeat that process of finding the standard deviation for the weights, you get a standard deviation of roughly 12 pounds. Now in order to find R, or the correlation, we need the z-scores, which are found by taking the difference between the score and the mean, which I already calculated while finding the standard deviations, and dividing that by the standard deviation. So in this case, for this particular z-score, I took the difference of approximately negative 6.23 and divided that by the standard deviation for x of approximately 1.65. And repeating that process for all of the z-scores for x, and again with their respective differences and their respective standard deviation for y of approximately 12 pounds, I found these z-scores for y. So in this case, this difference of about negative 17.8 pounds and the standard deviation of approximately 12 pounds, I have a z-score of approximately negative 1.5. But then in order to find R, I have to find the cross products, and the cross products just mean I took the z-score of x and multiplied it by the respective z-score for y. So in this case, to find this first cross product, I just simply took this z-score of approximately negative 1.6 and the z-score of approximately negative 1.5 and multiplied the two for the cross product, continuing that process all the way down the column for their respective z-scores for x and z-scores for y. Then I simply sum those cross products, and then in order to find R, I took the sum of the cross products over n minus 1, which in this case again is 19, for an R of approximately 0.96. This means that the height and the weight have a very positive, very strong correlation with each other, because the highest you can go for a correlation is positive 1, and this is positive 0.96, indicating that it is very, very strong. So when the height goes up, the weight goes up. Okay, so that is our R calculated. So now I want to add a scatter plot and add a regression line to our scatter plot. Usually you would do this by finding the slope and the intercept and using that regression line equation of intercept plus slope times the value of x. But in this case, my slope is almost completely unusable, and because I have no data near the spot where the y-intercept would occur of x equaling 0, because that would mean a person's height would be 0 inches tall, which is almost impossible, or is impossible, I should say. But the slope was usable, And using the equation for the slope, I found that the slope was around 7, which indicates that for every inch a person gains in height, they gain about 7 pounds in weight. So because my slope was almost unusable, I had to resort to using the trend lines provided by Excel. So I chose linear trend line because of that very positive, very strong correlation of positive 0.96. And so I simply chose trend line, linear trend line, and added that onto the graph. Thank you for listening to my presentation, and have a nice night.